Here this is boost converter based, PV based 7-level multi-level inverter. Here the PV is the source. The voltage is around 26.3 volt and power is around 200 watts. That is given to boost converter. The boost converter will steps up the voltage to 75 volt and provide as input to the multi-level inverter. The multi-level inverter, it will operates based on these capacitors, 3 capacitors. For 0 level, all the 3 capacitor will be charging. For first level, these 2 capacitors will be charging, this will be discharging. And for second level, these 2 capacitors will be discharging. For third level, these 3 capacitors will be discharging. So for positive cycle, 3 levels. For negative cycle, 3 levels. And for with 0 level, we will get totally 7 levels. Here, these 3 switches, it will provide the levels. And these 4 switches, it will provide the polarity, that is inverter operation, positive and negative cycles. And this boost converter setup, it will boost up the PV voltage to 75 volt in order to get the inverter to operate. Here each capacitor, it will get 25 volt. That means each capacitor resembles one PV panel because PV panel voltage is around 26. And here for that inverter, we are providing the SPPWM pulse generation. Here it is frequency is 1000 Hertz and system output voltage frequency is 50 Hertz. That is switching frequency is 1 kilohertz. System volt frequency is 50 Hertz. And these are the levels generated. Okay, 1, 2, 3, 4, 5, 6, 7. Totally 7 levels. Output current and voltage for RL load. Okay, and then THT we have to measure. Before that, we will see about here SPPWM operation. There are 3 steps for SPPWM. One is to find the direct axis, quadrature axis voltages, V reference and angle alpha from the input 3-phase voltage. From these 4 values, we have to find T1, T2, T0, that is time duration. And then switching time, that is delay for each switches, S1 to S6. This is for 3-phase inverter. So 6 switches will be there. Step 1, these are the formulas for conversion of VD and VQ from the 3-phase. Here if you see means, this is the conversion for transformation from 3-phase VAN, VBN, VCN. From that we are finding VD and VQ. And from VD and VQ we find V reference. And also alpha value, alpha equal to tan inverse of VQ by VD. So this will be provided as input to the SPPWM pulse generation. And from that, we have to determine T1, T2, T0. That is, for each sectors, we have to find these values. It will be splitted into 6 sectors. So each sector is for 60 degree, 0 to 60 degree first sector, 60 degree to 120 degree second sector, like that. We have to find the T1, T2, T0 values for each sectors. Okay, these are the T1 and T2 and T0 formulas. And step 3 is to find the switching time for each switch, S1 to S6. Here if you see means for each sector, the switching time will be varied. So according to that, we have to determine the switching time here according to this table. In sector 1, S1 equal to T1 plus T2 plus T0 by 2. And lowest switch, There is for negative cycle S4 equal to T naught by 2. And in second sector, S1 that is positive cycle is T1 plus T naught by 2. Negative cycle is T2 plus T naught by 2. Like that, we have to find the switching times for all the sectors. So once 360 degrees completed, again it will start from sector 1. And parameter calculations. That is input voltage is 26 volt for boost converter. And output voltage of boost converter is 75 volt. And power is 200 watts. So I naught is equal to 2.67 amps. And switching frequency we have taken as 18 kilohertz. From that, inductor and capacitor values we can find it and provide it to the boost converter. L and C values. FFT analysis. That is TST for PWM pulse with modulation generation. 4.16% we are getting. And with SVPWM, that is space vector pulse with modulation, 3.21% we are getting. So the THT is reducing with space vector pulse width modulation. So this is the working of that 7-level inverter.